I would like to thank the organizers for providing me the opportunity to talk about a topic I am deeply passionate about. I would also like to thank the attendees for their time. I have been working on the topic of measurement and optimization of viewer experience with pioneers of the field for more than 13 years. Media and entertainment industry has made great progress in bringing content to viewers in a wide variety of ways. At SimWave, we are enabling the industry to deliver desired viewer experiences on demand. Today, it is possible to control viewer experience on a per view, per device, per content, and per subscriber basis at scale by automating decision making based on viewer experience measurement across content delivery path from creation to consumption. I have shown on this slide a quality dial in the bottom left corner in green that enables a viewer to dial in desired viewer experience on their target device for the content they would like to watch, considering the constraints in place, obviously. The control does not have to sit with the viewer, as it can be achieved by a content provider on a viewer's behalf. Let's look at how the goal of delivering viewer experience on demand can be achieved. On this slide, we have content delivery chain laid out from consumption to creation with viewer first. There are two key ingredients required to achieve control of viewer experience on a per view basis or up to a per view basis. Eyes and brain. Eyes are deployed at various points in the delivery chain that measure all important elements of viewer experience and communicate those to a brain that is centrally located. The brain drives all intelligent parts of a delivery chain, such as transcoding and playback, using dials and switches. As you can imagine, accurate and complete viewer experience measurement by the eyes deployed at various points in the delivery chain is critical for achieving this goal. Let's take stock of the most important aspects when it comes to viewer experience measurement for the task at hand and compare various approaches. Let's look at the success criteria for a true viewer experience metric. First important aspect, content variation within an asset or live stream requires a viewer experience metric to assess quality without any bias. Otherwise, such a metric cannot be used for optimization across the board. For example, a score of 80 for sports, talking head, or animation content should reflect the same viewer experience. Second important aspect, a metric's ability to perceive all practical impairments like humans do is critical for optimization. Otherwise, optimized content may have lower perceptual quality than expected due to presence of impairments the metric could not assess. Or optimized content may have higher bitrate than what's possible to achieve due to higher sensitivity to certain impairments compared to perceived quality. This includes support for all encoders and codecs, as well as impairments beyond compression, such as lip sync and macro blocking due to packet loss, decodability, or syntax issues. Third important aspect, perceptual quality assessment varies across viewer types, such as studio viewers, expert viewers, and regular viewers. The goal of optimization may vary dependent on viewer type. For example, a studio viewer may primarily be interested in preservation of artistic intent. A video quality metric needs to model the psychovisual behaviors of all viewer types before it can be used for optimizing content in order to meet the needs of all industry segments. Fourth important aspect, real-world content is created, delivered, and played across multiple dynamic ranges, color gamuts, resolutions, frame rates, and scan formats. A video quality metric needs to support the content and display variations in an accurate and consistent manner across all the attributes. Fifth important aspect. In order to serve VOD, live, and linear optimization use cases efficiently and consistently, a metric needs to perform analysis in real time. Sixth important aspect. Source content fed into video compression engines is degraded and impaired more often than not. A perceptual quality metric may do a perfect job at optimizing compression, but it may just be providing a quote unquote garbage in, garbage out outcome, unless it can measure source quality in the same way it measures output quality. Seventh important aspect, looking at the video compression stage, independent of content playback and delivery, may make a perfectly looking content break content delivery and playback infrastructure. Also, video content is consumed across a wide variety of devices without accurate understanding of viewer experiences across popular devices used for typical viewing conditions, and optimization approach may be incomplete. SimPlus is the only viewer experience metric that covers all the bases in an efficient manner. Although this is a joint optimization problem, as the performance of each component of a delivery chain virtually impacts all the subsequent stages. For the sake of simplicity, let's break the problem in two steps. For the first step, let's focus on content acquisition and encoding. Encoding is always seen as a trade-off between quality and bitrate. The goal is to achieve ideal compromise between unhappy subscribers and cost. In other words, an ideal compromise may mean a service provider may still be losing customers in an effort to reduce content delivery cost. We all know that customer acquisition is very expensive and no one wants to lose subscribers, especially in this day and age. We are formulating the encoding problem as an engineering problem that does not put viewer expectations first. We need to redefine the problem, which is what I'm going to do in this presentation. We need to redefine the problem by putting viewers first. So we make sure that we do not lose subscribers due to unsatisfactory viewer experience. While doing that, we want to also decrease content storage and delivery costs. Fortunately, this is very much possible. We can achieve target viewer experience while significantly reducing content delivery costs using existing infrastructure by adding eyes and a brain to a content delivery chain. Here is how it would work. Let's say 80 is the target viewer experience you would like to achieve. A viewer experience of 80 on SimPlus scale is border level excellent and is better than most content out there. The histogram shows the performance of current state-of-the-art content-aware encoding approaches. Even though such approaches are able to steal bits from quote-unquote simple content, they are not able to provide any control over viewer experience. As a result of that, you have significant variation in viewer experience across a VOD library or channel lineup. SimWave collects SimPlus scores across tens of millions of hours of content in a month. This is a typical distribution of viewer experience. A significant portion of content either underperforms or overperforms the desired viewer experience level, both of which are bad. Overachieving viewer experience is bad because you are wasting significant dollars on this content. It is also bad to deliver lower than desired viewer experience. Please note that existing content aware encoding approaches do not fix these problems because they simply steal bits from wherever they can without impacting quality. So even if they do a perfect job, the state of your library stays the same, which means the histogram before and after using content aware encoding approaches looks the same. What can we do about that? You can actually solve the problem the right way by taking bits from content that overachieves and giving them to content that underachieves, like this. So now essentially you have converted a red block to a green block, free of cost. And you can continue doing that for all the red blocks until you have no more of reds left. But you are always left with orange blocks at the end because of two main reasons. Encoding is set up for the worst case scenarios using limited amount of content. Second, you can always save more from overachieving content than additional resources required by underachieving content if you're using the right metric. We are back at this table because I would like to make a point about the ability of a metric to perform consistently across impairments. You can very easily end up with many situations like these. As you can see, there is very obvious banding impairment in the content. If you use VMAF, PSNR, or structure similarity, you would be blind to various impairments even at high severity levels. Let's say if you're using VMAF to perform per title or per shot encoding, then you may continue to reduce bitrate even though you may be introducing a lot of impairment in the content. Now you know why Netflix content has banding all over the place. As you can see, the Simplus score is very low and it's in the poor quality range, which aligns very well with the subjective evaluation of quality as far as this content is concerned. Not only you need to accurately measure perceptibility of impairment, you also need to know where is the impairment. As you can see, Simplus quality map accurately shows where the banding is present. Let's see it all in action. Imagine you have a dial in your hand that you can use to deliver experiences that are just right using your existing video infrastructure while meeting delivery and playback constraints. Using the dial, you can deliver a world-beating viewer experience consistently, or a very good viewer experience for a part of your content catalog, or all of it. Now let's look at some real results achieved using the framework we just looked at. Let's start with a viewer experience level that will put you at the top of the world. Even at a world-beating viewer experience level, you can still save significantly at around 20% compared to the state-of-the-art content-aware encoding approaches. The viewer experience and savings are consistent across multiple commercially available encoders. Here you see results for two of those, encoder A and encoder B. What if your viewers are content with an excellent viewer experience? The savings would increase dramatically from 20% to 50%. What if your viewers are not as concerned about their viewer experience and you would like to deliver a very good viewer experience so you can save some more? At a viewer experience level of 75, you can save a whopping 70% on top of current content-aware encoding approaches using existing encoders. This concludes step 1, which is about content creation. Step 2 is about content delivery, playback, and display. As I have run out of time here, I would like to say that most of the principles used for step 1 are applicable for step 2. As long as you have eyes, in other words, an accurate metric like Simplus that measures viewer experience from content creation to consumption. With that, you can achieve desired viewer experience by region, by device, by viewer, or even at a per view level. You can reach me at abdul.rehman@simwave.com. Please let me know if you have any questions. Thank you.